Thank you very much for coming along today. What I'm going to talk about today is, well, logging. Originally, this track or this session was called Log Analysis at Scale. But then as I sat down and started to write my content and think about how I wanted to approach this, I realized that before even getting to the analysis stage, there's a lot to do. So what I want to do today is I want to talk about logging at scale. Now, logging is difficult, and I knew this when I started because my background is building big platforms, and I kind of knew this. So I thought I knew this, but when I actually sat down and thought about it, and I thought about the scale at which you have to operate, it's incredible. So when we build platforms that go from no users to within 5 minutes, it goes up to 80,000 requests per second, the platforms that you need to build to actually manage this kind of infrastructure are incredible, because you have to take this data in. If you're working in somewhere where this very logging data will actually affect your ability to bill your customers, you can't simply just go, okay, well, I'll discard half the messages. But it really is difficult to capture, process, store, and deal with this volume of data reliably time and time again. We can break these problems or these opportunities into 4 major areas. First of all, you need to store them temporarily somewhere. You need to then capture them off those instances. You need to permanently have somewhere for those to live. And finally, you need to be able to visualize or actually address that log data. In the interest of scaling myself, I've decided to steal a large amount of content. This is Joel Williams, a solutions architect for Amazon Web Services based out of the US. At our global conference reInvent, he talked about scaling to your first 10 million users. I recommend anybody have a look at that if you're building large platforms. I provided a bit.ly link to the talk there, which is hosted on YouTube. What he talks about there is the ability to grow every component of your architecture. Often your architecture, your platform, when you are 1 user or around 1 user, will start out looking a lot like this. It's a very simple single server setup. Maybe you use Amazon Route 53, maybe you have a single elastic IP address, but you have everything on 1 instance. You have your database server, your web server, your application server, all on 1 instance. So with 1 place, 1 instance, it's a single place to read logs from. And with a single place to read logs from, you can get away with a lot. So my background is bad shell scripting. And if you look at some of the things that you tend to write in your history, it'll be things that my ex-colleagues, some of whom are here today, will call AlexJS hacks. These are hacked together bits of awk and grep and Perl that eventually get you insight. Like, it's very common with Apache to see, well, what are my top URLs? Or what's the most common HTTP response code? Or my top user agents. Now, all of these are very easy for you to fetch in because you're only dealing with 1 server. Hey, you could even write a little more complex bit of Perl and look at request lines per second. This is easy when you have only 1 server to deal with, or, in fact, with a couple of servers. Cluster SSH, a bunch of terminals, you look a little bit like the movie Hackers, and it works. But when it comes to dealing with larger infrastructures or real life, it's never that easy, because the architectures tend to look like this. And that's true whether you're dealing with 1 million users or whether you're dealing with 1 user. So when you go back to your simple architecture and you think, wow, I could use all those hacks there, it works really well, you can't when it comes to the actual production. And this is true whether you're dealing with 1 million users or even 10,000, because as your architecture, as your platform becomes more complex, you spend more time building these disparate systems, and that's more data that you then need to evaluate. And all of this is at the server level. We're not even thinking about the users themselves. If you're dealing on a video-on-demand site or a social network or anything, in fact, with a mobile application or a website, you're getting enormous amounts of data in from the client itself. Are you actually capturing these? Because we can't ignore that. So with all these different bits to bring into the platform, we end up with these problems. Now, I hope to walk through various different ways for us to deal with the problems and unlock a simple piece of insight from each of them. So I'm going to start with the temporary storage. Now, what I mean by that is when the logs are actually written. You've got a few different options here because your application could just write it straight out over to the network. You can temporarily stage it to a local disk, and there you have a couple of options about how you actually address that. In Amazon Web Services, you have ephemeral volumes. These are very low cost because they are free. They do not persist across reboots, but they are directly attached. This allows you to very quickly write gigabytes of log files. However, in the event of the loss of a system, then you lose your data. If you're working in banking or anything where forensic data would be required, this wouldn't work for your kind of use cases. So to get around that, we have the Elastic Block Store, which I hope, given this is a 300-level track, many of you are familiar with. Now, this has a range of different storage options. By default, many people will go with GP2, or general purpose disks. But we recently, at the Chicago Summit a couple of weeks ago, announced a new form of magnetic hard drive called the ST1 or SC1, depending on your warmness level. This gives you the ability to do much higher megabytes per second at lower IOPS, meaning actually for things like logging, this is ideal. So I recommend when we look at where you're temporarily storing your logs, actually looking at an EBS volume, but some of the cheaper options there may well be the right choice. There's nothing to say in an application you can't immediately write over that network, but if you're using something like a UDP transport, keep in mind that that is inherently unreliable. And if you're relying on this data for billing, keeping a copy of the log file somewhere locally where you can be recovered is very important. So now we've addressed the storage, we need to think about how we actually get these off the instances themselves. So I was going to talk about capture now, but first I want to get the thing somewhere to live, and then I'll walk through the capture and how to get it over there. This will have a few live demos. Just before all you guys came in, my internet worked fine. Then you guys came in and it stopped working fine. So I'm a little bit nervous now, but it's okay. Because what I'm going to talk about here is the problems of persistence, and by that point, it should all be okay. So there's three main issues with persistence, and in this context, the persistence of logs. First of all, it's somewhere to stage those logs. Now, when we think about staging, it's the temporary storage place. It's the here it lives before I actually process it. Off the instance, but before its final resting place. I need the final resting place itself, and that needs to be scalable, it needs to be accessible, it needs to be the kind of thing that I can grow as my platform grows. And finally, I need a way to search my data. It's no use having terabytes of log files in tapes in a warehouse, because I don't have any access to that data. Now, many of you could be looking at this and thinking, well, surely that's a really good fit to a NoSQL database. And I'm back to stealing content from the architecture talk here. Well, some folks won't like this approach, but start with SQL databases, even MPP SQL databases like Redshift. And there's a good reason for this. Well, SQL is incredibly well established. There's tool chains that exist for it. There's a huge amount of knowledge available on the internet or even in your teams today in the best way to manage and build schemas for SQL databases. And to be frank, unless you are doing incredibly strange things with your data, you aren't going to break a SQL database in your first 10 million users. And of course, because this is very established, it's easy to scale big. This may be through things like sharding, which fit incredibly well into an analytics suite. Now, there's a small caveat here, which is sometimes, I'm looking outside of logging, but sometimes a NoSQL database is the right choice. And that may be where you have things that you are doing very strangely with the data, or it's data which is so unrelational that it doesn't actually have any reason to sit within that constraint. Or if you have massive amounts of data to process. Now at this point, people often go, aha, you said the word massive. I have huge amounts of data. Now let's think about what you actually mean by huge amounts of data. Because in a NoSQL database, you end up having to manage many, many more components of a platform that you may not be familiar with. Now within things like Redshift, our MPP data warehouse, you can scale to petabytes of storage. So don't get too worried about the size of your data today. Think about this path to scalability. Because if you look at the reasons for NoSQL, super low latency applications which don't apply to log ingest, metadata driven, not so much here either, and your data tends to have relationships. So ruling those out, where you need schemaless constructs, where you need to ingest large amounts of data, where you need to do that quickly, that can still be done through different services which Amazon offer today. So let's look again at these three areas of persistence and break them down one by one, and I'll map an Amazon component to it, and we can talk about and maybe even set up, internet connection willing, that particular service. So let's start with the actual architecture of a log dispatcher, because you do need somewhere for the logs to actually be staged. Today I'm going to talk very specifically about the Kinesis Firehose section of this infrastructure. So on your instances, you may have a dispatcher, log stash forwarder, or an agent which sends those logs off, but they need somewhere to live. So in this architecture, I've talked about the app server sending to Kinesis Firehose. But at that point, the logs still need somewhere to be staged. S3 is the simple storage service from Amazon. It scales to virtually unlimited amounts of storage very easily, and you only pay for the storage you use. It also has support for AWS Lambda, which is talked about in the very next talk by Marco. The event-driven computing nature of Lambda allows you to do operations as files come in. This means that you no longer need to worry about watch folders or long-running batch jobs that just pick up files as they come in. This is automated for you. And S3 is fantastically integrated with services like Redshift, services like Firehose. So this makes your life easier as you're building a storage-driven architecture. So I'm going to assume S3 is my staging area. So my next option is somewhere to live, and specifically somewhere for the long tail to live. And this is where Redshift comes in. Redshift is a petabyte scale data warehouse. It can scale to 1/4 of an exabyte. This is the lowest price point for a large-scale data warehouse. This is also Postgres-based. This means that you can continue to use many of the business intelligence tools that you're familiar with today, and your data scientists, your data engineers, can continue to use a lot of the platforms that they have already grown their career through. We give you a choice of nodes depending on your workload type. Sometimes it's very dense compute, you need to process a lot. Sometimes it's very dense storage, when actually you have more things that need to live cold. And this can ingest from S3, whether that's stored in CSV or JSON or any other form. So now I've decided where it's going to live, I need an index, I need some way to search it. And this is why I'm going to talk about Elasticsearch. So Elasticsearch ELK is a very common choice when it comes to logging. Elasticsearch service was offered last year at reInvent. It allows you to very easily run an Elasticsearch cluster on AWS. Much like RDS, the relational database service, we take care of the installation, management, and upkeep of an Elasticsearch cluster. We also pre-package it with Kibana for visualizations. We integrate it with IAM roles to make it more simple for you to manage and control access inbound to your platform. And it has built-in support for things like Kinesis Firehose for the actual data load-in the first place. So with all three of those problems hopefully addressed by one of these services, now I'm going to actually, theoretically, very quickly demonstrate the setup of Elasticsearch service itself. So to do this, I'm going to switch over to a browser window. There we go. For those of you familiar, this was the AWS console. May look a little bit different. But yes, this is the AWS console as of today. You can see I've already created one Elasticsearch service cluster. But for this, I'm going to create a new domain to allow us to just run through this demo. It's very much as simple as creating your domain, choosing some of the characteristics about it, and provisioning. We allow you to predetermine the size of your cluster if you know you're going to be loading a lot of data in up front, or alternatively, you can change the size of a cluster after it's provisioned, depending on your varied data as time goes on. So by default, I'm just going to leave this as a single instance. However, there's a couple of things I want to draw your attention to. Elasticsearch allows you to have a dedicated master, which we recommend for production deployments. This offloads a large amount of the processing onto a separate section of the cluster, for instance, helping you with the visualization section. We also have zone awareness. Zone awareness means that you can use the same model of availability zones, the same model of high availability that we have in all of the other Amazon components. You do need to take this into account when you're building your Elasticsearch compatible applications, but for things like Firehose, it's dealt with automatically. So with that, I will skip through very quickly and just talk about the access policies. I said one of the best bits was how IAM access is built in, which is fantastic. So what I can actually do is I can just say, allow access to my AWS account. I can add my account ID in here, and it pre-generates an access policy for me to allow me to actually control access in there and only restrict it from my account. Now, what I can also do is, if I wanted more public access to, say, Kibana, the visualization front end, I can modify that policy, and I will change that to my principal, my ARN. I can modify that policy to have multiple statements. In this case, the first of which allows access from the IAM address, and then a second one, access from the IP address. I can mix and match this, and it means that I can integrate non-IAM compatible components of a platform, which allows backwards compatibility with things like on-premise. So with that, I've determined the size of my cluster, I've created my instances, I've created my zones. So I'm going to press confirm and create. I've hit my account limits because I didn't set this up properly. So what I will now do is I will talk about the one I created earlier, as I always do in a Blue Peter style way. So the one I created earlier, thank you. Good timing on the laughter there. The one I created earlier is available here. What I've got here is this very similar domain to the one that I just walked through with the very same kind of access policy. The only difference is I'm already ingesting data into here. So now I've got somewhere for my data to actually come into. So I'm going to switch back to my PowerPoint, and I'm just going to talk about getting the data there in the first place. Now, once the data actually comes in, and for the purpose of this demo, I'm going to always use Apache log files, a very easy and very common requirement. When data comes into Elasticsearch, we treat it as a time series data. Now, with this, we need to be able to analyze the date format and the other components of that. So I just want to highlight a couple of things about Elasticsearch mappings or types. These are ways that we pass the incoming data and actually evaluate it within our index. Now, what you can see here is I've isolated the date, and I've also isolated the user agent. There's two things I want to raise, and first of all, if you're processing this in a real-world scenario, you're using the same kind of setup I'm talking about, please make sure that you actually pass your date time properly. If it comes in as a string, you can't treat it like a filter or treat it like a searchable field. Secondly, when data comes into Elasticsearch, by default, it's run through a parser, separates into different English words. If you intend to use things as a filter on user agent, on path, on anything like that, it doesn't work well. You can individually set the fields to not be analyzed. So when you create your mapping, please do keep these in mind. I believe these slides will be shared afterwards, so just have a look at those. So now I've got somewhere to store my data, I actually need to get it off of the instance in the first place. And how do I do that? What approach do I use? So many of you will be familiar with things like the log-stash forwarder, or even building things into your application. Going back to my logging architecture, there's two components I'm going to talk about here. Because there's two very difficult problems. The first is sending data off of your instance reliably, but the second is having somewhere to send that data that can scale from 0 to 10,000 requests per second in 5 seconds. So what I'm going to talk about is, first of all, Amazon Kinesis. You may be familiar with this service, a stream processing service. It allows you to very quickly scale to huge amounts of JSON objects incoming. And you can write applications in what we call KCL, the Kinesis client library, to take data off that stream and actually parse it. Apps can be written in Java or many of the Lambda-compatible languages like Python or Node. And this is fantastic. However, you still have to write an application. So at reInvent last year, we released and updated Kinesis. Kinesis is now Kinesis Streams, or the classic Kinesis. You still have the flexibility, you can still write your innovative apps, but we've also created Kinesis Firehose. Kinesis Firehose is a completely managed data ingest service. Given an HTTP endpoint, you send data in and it persists it to Redshift, to Elasticsearch, or to S3. And sometimes, in some cases, you can do more than one at once. And that's it. It's incredibly easy to use. However, you still needed to write an application to talk to this. And you saw my shell hacks earlier. They're terrible. I'm not a developer. which is great. We released 2 weeks ago, as I was writing my slides, something that meant I didn't have to write any code. The AWS Kinesis agent allows you to read log files and manage log files and then send them in to Kinesis Firehose. It's a Java application, it's open source, it's easily available, and it's ready today. What you can do is you can take in things like single-line files, you can take in CSV, but most importantly for me is you can take in log files and it will automatically convert them to a JSON object for import. And it actually supports Apache logs like we're dealing with today. So, again, pray for me, people. What I'm going to do now is very quickly run through the setup of, first of all, Firehose, the endpoint, and secondly, I'll talk through how the ingest agent works. So if I just go to the console once more, and I have a look at Firehose. Firehose is split up into different delivery streams, which are an ingest point and an output point. In this case, you define an index in the Elasticsearch domain for me to actually persist the data to. For my delivery stream, I've already created one, but I'll just quickly show you some of the options we have. So we can select S3, Redshift, or Elasticsearch. In this case, we want to use Elasticsearch, and I'm going to use the delivery stream name AlexJS demo live. I can choose my existing Elasticsearch demo, and I can choose a new or existing index. And here I will choose my live one. We also support rotation of indexes, so if you have data that's only valid for a day or a week or a month, you can automatically cycle that out in a batch. One of the best bits of Firehose is it deals with failure really well. If you have a connectivity issue between your log aggregation server and your log persistence destination, you're in trouble. Firehose deals with that piece entirely for you. And also, in the event of a log message coming in that's malformed, you still need to be aware of that. Firehose allows you to persist failed documents, or alternatively, all documents, into S3. And earlier, when I mentioned that you could output to 2 places at once, using Firehose to both write to an Elasticsearch cluster and also persist data to S3 means you can then use that S3 data to load into Redshift or your RDBMS of choice. All messages are output as JSON files in aggregated blobs. So with that, I'm just going to quickly go back to my already created Firehose delivery stream. Now, the output for this is my earlier created Elasticsearch domain. But I do need some way to send data to it. So what I have here is a terminal, and I will log on to a Bastion host. As many of you'll know, it's best if you can have your web servers with no public internet access. I've already set up a web server, which is available now. You can see I've got some amount of traffic coming in. Lots of requests from my load test machine. And that is running right now. But I still don't have any way to get these logs off. So I choose to install the AWS Kinesis agent. That's available with Amazon Linux, but also available on GitHub, and we provide packages there. As that installs, I can then just write an agent configuration, which has a couple of components, and I will use one that I have prepackaged here. So in this, what we have is a few different pieces. First of all, we deal with the files, or specify the files we want to deal with. This takes patterns if you have files which automatically rotate, or you want Firehose to handle that rotation for you. We also specify the delivery stream, and in my case, I called it, as I go back towards here, logging at scale -demo, so I will remove that. And I specify the way I want to treat my data. So in my case, I chose to convert the log file into a JSON object, and I use the log format combined Apache log. So that's very familiar for those of you who use NCSA Apache logs. Now there's one more important thing, and that's credentials. How do I stop anybody just sending data in? Now if you're familiar with IAM roles for EC2, they're an incredibly easy way for you to grant an EC2 instance itself access to do things. Now, this access might be writing to different services. It might be manipulating the EC2 instance itself. So within this web server, I've applied a role that allows me to write out files, to access my Elasticsearch cluster. Finally, I'm just going to check the permissions. So in the HTTP directory, it is owned by Apache, and the log files are world readable. So with that, I should be able to start my Kinesis agent, starts the Java application up, and then in the agent log file, it takes about 30 seconds to start processing these. It dispatches data in every 30 seconds, and then Firehose starts to buffer that. So while that starts to buffer, I'm just going to quickly go back to my delivery stream and just show you a couple of the stats around here as well. So within the monitoring section, what you can see is the kind of data that's coming in, the freshness with S3, and AWS Kinesis agent also supports CloudWatch metrics. So in the event of a dispatch failure, you can get an alerting through that using the same kind of model you may do for the rest of your AWS platform. Now, because I've got a large amount of data here, the Kinesis agent has gone, I'm already behind, I need to catch up. You can see here that it's processed 100,000 records already, and it's desperately trying to send this data in to catch up. That gets added into my existing Elasticsearch index. So in the event of an instance becoming unavailable, we don't miss anything. We still can bring that data back. Now I've got my data coming in, it's reliable, and it's scalable. So now I need to think about what I'm going to do with my data and how I can actually see it. So let's go back to the PowerPoint, and let's just continue running through there. So once I've got my data in, I persist it to S3, and I also load it into Elasticsearch. As I mentioned, this gets stored as JSON blobs in S3. I can load this into Redshift very easily, and it's easily available. Within Elasticsearch, my index keeps growing. When I took this screenshot a couple of days ago, I had 700,000. Now I'm up to 3+ million. That continues to scale, and I can see my utilization. I can see my growth. Now, once I've got this data, I do need to visualize it. I actually do need to do something with it. So how can I address that piece? Well, I want to talk about Kibana. Kibana is actually pre-integrated with the Elasticsearch service. This makes life much, much easier when you're trying to manage it because it's all within that same application. Kibana also doesn't deal that well with very high latency networks. So by co-locating them both within AWS, you reduce the complexity and improve the performance. Within Kibana, it's very easy to quickly visualize and play about with your graphs and get very quick insight on what you're trying to do. But that doesn't have to end there. You can continue to use your same BI tools. Many of you will be using things like ClickView or Tableau or Tibco or Pentao. Now, these have ways for you to access into Redshift. Redshift has SQL drivers available for almost all of the major BI vendors. So if you're already using these, integration should be quite simple. Now, I'm not going to spend too much time on this because I really want to just point out some of the very quick graphs that I've already rendered in Kibana. So if I just go back to my Kibana installation, first of all, I want to talk about the security of Kibana. So Kibana is, in this case, IP secured. So if I try to open this, I will get an error saying, actually, you haven't authenticated to me, you're not allowed. Now, as I mentioned earlier, I was running this through a Bastion host, so that does allow me access in over an IP whitelist. Kibana will pre-cache a lot of its index for me, so it's nice and easy for me to have that preloaded. And then once that's registered, what you can see is the same data that we saw on that EC2 instance. This is serialized from a log line into a JSON object, and each of the components is split up here. It's very easy for you to do filters on different sections, to do quick visualizations, or even just explore and discover your data. So for instance, I've got a load balancer and I want to make sure that the traffic coming in is reasonably distributed between those two. Well, I can see of the last 500, it's about 50-50. So yes, it's working well. But when I want to start doing more visualizations, I've got a range of options available to me that I can quickly create. If I want to create a line bar, just based on traffic over time, I can do that with, I think that was 5 clicks. And then this same data is available to me to do a wide range of different things. And some of the talks that you'll see today around IoT and other components use the same approach to show completely different kinds of data. And once I've built several visualizations, I can load this into a dashboard. That dashboard becomes incredibly easy for me to then have as my network operations center dashboard, or even something my developers use to know the health of their instances. It uses the same visualizations that I created in the other section of Kibana, and they load into an easily customizable dashboard. So with that, I want to try and wrap up now. So I feel like we've dealt with the technical problems, but what this doesn't deal with is the insight. You as an organization still need to provide insight into your data. You can provide these tools, you can use the existing BI tools, but you still need the data engineers, you still need the data scientists to do this. But hopefully by doing things like this, you remove the barriers to actually taking your data in and parsing it. So to recap, I still think logging is incredibly hard. We make life easier. We provide you plugins, we provide you software, we provide agents to take that data off, and very scalable services for you to take that data in. But it's still hard to do. If you use tools like Firehose, the Kinesis agent, Elasticsearch service, or even Redshift, it does deal with a lot of those core components and make life easier. But where you can, you should reuse the data, so send to multiple Firehose endpoints at once. Reuse the tools if you already have visualization tools, endpoints, things like that, and reuse the people. Don't think just because you're moving to Kibana, you get rid of your data science group. And please, again, don't be big data dog. Use your time cleverly and know what you actually need to do. So with that, as I said in my earlier talk, Amazon is a human company. We're based for our Asia-Pacific headquarters in Singapore. We have drop-ins almost every other week in the office. We have the AWS user group, which is incredibly popular. Please do come by, talk, and learn.